Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with the leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Bill Freivogel, Vice President Sales and Marketing, Cumberland Additive. On today's episode, we'll discuss how Cumberland is leading the growth of additive manufacturing in Pittsburgh. We hope you enjoy this episode. Bill, welcome to the podcast.
Thank you. Appreciate the opportunity to be here.
It's great to have you here because point blank, additive manufacturing will play a large role in the future of manufacturing. For our listeners who are not familiar with additive manufacturing, how would you describe it to them?
Sure. Yeah. So it's also known as 3D printing. And I think it's important first to level set on the technology that Cumberland Additive in particular uses or leverages in the marketplace. So there's a lot of acronyms out there. DED, binder jet, DMLS, SLM, PVF, you name it. Directed energy deposition is DED. Binder jet's a different technology. But for us, we participate in the laser and powder bed fusion technology. So we would consider it the most industrialized technology out there. And we convert a 3D CAD model from our computer to a physical 3D printed object. So if I go back to laser and electron beam are the energy sources used to manufacture the part, and weld them layer upon layer, thus additive manufacturing, you're building up from your build plate. The feedstock is powder, whether it's a metal or polymer in our case, variety of different materials. And really, we just continue to build this part, layer upon layer until you have your physical object within the build chamber and an inert atmosphere for powder bed fusion.
Are your parts stronger, lighter, sturdier? What is that competitive advantage from the process that you use versus just a typical 3D printer?
A typical desktop printer is very different from what we do. In the fact that we're supporting aerospace, defense, energy applications that are used on these vehicle systems and assembled into aircrafts, for example. But our post print, it's really 99% dense product without any additional post-processing. So without any further heat treat, you're getting a part that's 99% dense. So similar or improved, mechanical properties, yield strength, tensile strength compared to traditionally manufactured products, like a forging or a machine part. High resolution, capable of parts with fine detail and actually pretty good volume as well. So it's fun to print things at home. That's a great way to start getting into it, get the idea and the concept going. But for what we do, it's more industrialized.
For the aerospace, for example, is that because the cost savings to manufacture those parts, or is it the time saving? What is that big draw that's drawing the aerospace industry into additive manufacturing?
Yeah, so that's actually where we got started. So we're a 16-year-old company, and we actually had the first titanium 6 AL4V bracket that was certified and flown on a commercial aircraft around the world. So it for them, it's another tool in the toolbox. It's not going to replace everything. It's just another way to manufacture parts, taking advantage of parts that are complex that maybe you otherwise could not have produced traditionally. Maybe you're reducing weight because you're only printing the material you need to get to your final component, and potentially reducing lead times and taking costs, out of the supply chain as well. So for aerospace, it may be metal applications, it may be polymer applications as well. And in cases where if we're doing parts that are required maybe in the final interiors of an aircraft, those are some of the last things that are completed and manufactured. And we're able to do things pretty rapidly and quickly to meet up with their critical lead times. Also, if you think about it from a research and development and a prototype design through finished product, for aerospace, it allows them to have some more flexibility in design to make those changes with less tooling, less non-recurring expenses versus some traditional products where to redesign, you've got to completely retool. And there's certainly a big cost to that as well.
When you look at parts for aerospace, are you shaving off ounces? Are you shaving off pounds, or does it just depend on the part?
Sure. Yeah, it depends on the part, but I would equate it to pounds, and pounds means big dollars in aerospace. Any pound removed from the aircraft, buy-to-fly ratio is obviously huge given what they can do from a gas and economical standpoint.
Okay, I'm putting on my Wall Street hat here. I read from one of the big banks. I read a report about the weight loss drug Ozempic now, and it said for this airline, and I'll remove them. They wanted the passengers to lose weight, and so they're encouraging this drug. If every passenger on the plane was 2 pounds lighter, the amount of the profitability would go through the roof. This was from a big Wall Street bank, so that's not going to happen because you're going to invade somebody's rights. But what you're doing is you're offering a solution where you have 100 passengers on that plane, 200 passengers. Let's just do simple math. So 200 passengers, that's 400 pounds. If you used your technology, you can save that 400 pounds without getting into a political storm. Why is there not more attention paid to the advantages of what Cumberland's doing from a weight perspective, since weight is so important? And we could look at this years ago. Remember, United got the seat backs, the screens to save weight until the customer uproar said, "Oh, we have to have them back." But the customer's not going to know if it's a additive manufactured part versus a traditional part. So to me, it seems like that's a huge growth market for you.
Yeah, it is. And I think there's a couple of things. There's the adoption of AM, so the adoption learning curve, if you want to call it, and say one is an early adopter and 10's, late. So in other words, the one, they may have already gone down that path of developing the specifications and requirements. That additive manufacturing can give them the results and the specifications they need to meet their rigorous requirements compared to, say, a forging or a hog out of a plate billet. So part of that is there's a cost to adopt AM parts and get them placed onto an aircraft. And does that process and the time it takes to get it there offset the cost of the weight reduction? So the business case absolutely needs to be there. And I think the adoption has increased tremendously over the past 5 to 10 years in aerospace. And I think the more they start designing for additive from the ground up on future aircraft, it gets a little easier than going in midstream and replacing a part. They're taking advantage of it for spares and aftermarket, so that's a good opportunity. But in some cases, it may just be more cost effective to use traditional. I mean, it cannot replace every part in the aircraft. It's another tool in the toolbox. And when applied and used properly, then they start to unlock that value and cut some of the costs on the weight. With topology optimized parts, organically grown parts, because you got to think not just aerospace, but also space applications as well. So unmanned versus manned leads to different opportunities as well.
A major airline years ago took me on a tour of their maintenance facility, and there was an area behind a curtain I wasn't allowed to go to. Said, "United States government property, do not go over this line." Yes, sir. You're going deep doo-doo land if you do that. So I didn't want to go into deep doo-doo land, so I didn't go over the line. But they had all these co-located repair facilities inside of their main hub. Hypothetically, could Cumberland co-locate at one of these major airlines or a large airline manufacturer? Could you co-locate your system inside of there to increase the time to bring it closer to your end consumer?
Yeah, absolutely. So I would say I think that's definitely the future of additive manufacturing. In some cases, how do we get closer and closer to the end user? And in cases with aerospace or space applications, a lot of our customers have captive capabilities. I mean, they brought printers in-house. And in some cases, it's a good thing because, one, they start to better understand the technology themselves. They start to build their own technical database, what they can and can't do. But there's plenty of capacity needed and opportunity to go around that. It helps move that process along for Cumberland. So if we were to place a printer there, it's certainly something that could happen. But at the end of the day, it's not, unfortunately, as easy as print, hit the button, and print, and voila, out comes a part. There's a lot of ancillary operations. There's a lot of tribal knowledge, a lot of overcome challenges over the years that are put into to getting to where we are today. So in those cases, we would certainly be collaborating from not just put a machine there, but also personnel and people. Because really, at the end of the day, it's about the people operating the machines that know what they're doing, coupled with the engineers, et cetera, and operations to manufacture these parts repeatably.
What does it look like from an infrastructure standpoint, whether in the Cumberland office or in an office? Do you have to have a clean room to operate this? Do you have to design something special? What does it look like from an infrastructure standpoint?
Yeah, so for what we do, we don't have a clean room. We have pretty phenomenal manufacturing facilities. We actually just opened one in Pittsburgh. The nice thing was we got to see that from ground up, greenfield all the way up. But as it relates to the products we're manufacturing, we don't need necessarily a clean room. As we branch into more medical components, which is something we're doing from a strategic diversification standpoint, that could be in the future where we get there, but there's definitely some building blocks before we get to that point in the future. But yes, others do have that capability.
Cumberland has the presence in Texas. Why expand to neighborhood 91 in Pittsburgh? Was it the town of the university system? Was it the overall ecosystem for additive manufacturing? Why did the expansion to Pittsburgh?
We needed additional capacity, and we saw this tremendous opportunity at what we believe is a game-changing additive manufacturing campus. So let's step back and level set on what this ecosystem has been called. So it's called Neighborhood 91. So Pittsburgh has, or is known to have, 90 neighborhoods, and we're calling this the 91st neighborhood because it's truly a neighborhood. It's an ecosystem beginning to end for additive manufacturing. So one of the reasons that we came to this campus was the fact that you have everything done under one roof and in one community. So logistically, when you have powder manufacturers on site and they're handing the powder off to you to then put and load into your printer, and then you print, and then you do the post value added processing like CNC machining if required, or heat treat, and then final inspection, all there on the campus, and then have access right there to the Pittsburgh International Airport runway to ship product anywhere in 24 hours. That becomes a logistical game changer, cutting down costs, and you're certainly helping from a logistics standpoint. And then if you think about Pittsburgh, in addition to the airport, major highways, rivers, good logistically, and then being on the airport grounds, good, strong resiliency from an energy standpoint. So we've had power outages at our facility. Believe it or not, Texas and Austin, Pflugerville, where we're located, had a catastrophic storm a couple of years ago, shut down our printers, and that's terribly expensive. So in this case, a second facility offers some additional risk mitigation should we face that in the future as well.
I'm going to use the term insourcing. You said you have your suppliers there for the powders. Is your, let's say, the Cumberland supply chain all inside of neighborhood 91? So you can go knock on supplier ones, or hey, where's my stuff? Go knock on supplier two. Hey, where's my stuff? Instead of trying to go all over the world to find it, is it all located in there? Or is that the overall vision of where this is going?
Yeah, so that is absolutely the overall vision of where it's going. Still in the somewhat early stages, but there is a powder manufacturer already on site, Powder Metalworks. And so we continue to see that being the way of the future. We also have a separate building that stores the powder material. In some cases, you have materials that are reactive, highly flammable, or just given some of the regulations that we strive to follow in the rigor with how we separate the powder and keep it in a secure location as well with good security measures. That's another advantage. So we've got quick access to it. But yeah, that's the goal, Grayson, from beginning to end for all operations to be under one roof. For Cumberland in particular, our core competencies are additive manufacturing, 3D printing of metal and polymers, coupled with CNC machining solutions. So adding final machining. And then we go and final inspect and provide to our customers a finished component for built-on assembly. So taking the risk out of it for them, delivering them a finished product. So for us, we may not have all those in-between processes under our roof, but we got our core ones. And if we can leverage local heat treat and powder manufacturers, because we don't actually manufacture the powder, we buy it and then print it. Let's leave that to them and their expertise. But we certainly become more dangerous if we got access to that right there on site. But even now, another good advantage of the campus makes me think of this is we use 6K additive, and they're in the Pittsburgh area. So within 2-hour radius, there's already pretty robust and well-established suppliers that are needed for additive manufacturing technology as well.
Is the powder trade as a commodity as corn, soy, pork, oil? Is it a commodity where those prices are constantly fluctuating based on market demands, or is it a pretty fixed cost?
It's a pretty fixed cost, but it really depends on the allying elements and what's going on. There's so many factors that go into it, in my opinion. But so far in the 4 years that I've been with the company, it's been fairly stable within reason. And what we do is secure, long-term agreements and so forth. I can't get into the details of those, but that certainly can help in some cases. But Yeah, that's I think that's all I'll say on that side of things.
You have to you have to secure your oil to make your engine go, or if you're a battery, to get your electricity to make your battery electric vehicle go. So we have all the components to go. You have your ecosystem, let's call them friends and partners inside the Pittsburgh region, inside of Neighborhood 91. What type of capacity output is Cumberland looking to achieve in Pittsburgh?
That's a big question in terms of, I think, how you look at it and how you dissect capacity. But for us, in a short year, we've already become AS 9100D approved, and we're an ITAR accredited facilities. That certainly helps with, the likes of aerospace, defense, energy, medical companies, and so forth. And in that case, in that period of time, because we've had an established company out of Texas, where we're running 15 plus printers, we were able to, in some cases, extend that as additional capacity, as well as bring on new products. One example, we're supporting the RME, Resilient Manufacturing Ecosystem, a defense program, as well as other programs in the defense space and aero there that I can't necessarily get into the details of due to the confidentiality and so forth in the ITAR, regulations there. But we're humming. We're humming on all cylinders. We're pretty much at capacity there. And it's fun to have the conversations with those who decided to actually move to our facility. One of our colleagues actually moved from Pflugerville, Texas with his family to capitalize on the opportunity. So he took his CNC machining capabilities. He's now running our CNC machine shop there, but also cross-functionally trained on our SLM 280 machines, our printers we use to make the parts in Pflugerville. Well, so he could then, support the SLM 500, similar architecture, but another like family printer in Pittsburgh. So between him and colleague Kyle, they're able to work and cross-functionally support there. But the questions and the things that I hear, when are we getting more people in here to support? So that's where we're headed. So we built it to then add more printers and add more CNC machining and other ancillary operations over a period of time to get us there and keep growing. So really, it's just a matter of how many printers can you get in there and continue to mimic and offer some diversity there.
A hypothetical, Pittsburgh's up at full steam. You're happy. The business team's happy. It's operating at full steam. You have the facility in Austin. Will different objects or parts or be printed in different locations? So you have different machines that will specialize in one form of printing versus another? Or is it just going to be closer to the customer? How are you going to divide up that workload?
Yeah, sure. A lot of it comes down to the material, for one. Is it aluminum ALSI 10mg? Is it titanium 6.4? Is it a nickel 718 and so forth? So which printer's loaded with that material? Because we like to keep a printer loaded with one material and ideally running serial production parts over and over again. And then also the geometry of the part. So what type of geometry? So does it fit a mid or a large format printer? How many can you nest? How can you orient the part on the build plate to get efficiencies and all of that good stuff from an engineering standpoint? And then to go back to where we started earlier in the conversation, comparing laser to electron beam, is the part better suited for electron beam or is it better suited for laser powder bed fusion? And that comes down to the specifications requirements that our customer flows down. Like, for example, electron beam, in some cases, you may be able to vertically nest parts, whereas laser powder bed fusion, you're nesting what can only fit on that build plate, and they're anchored down to the plate through support structure to help with heat, stress relief, and dissipation. So it just depends on part geometry, materials, and working closely with our customers on a design assistance to determine which is the best solution for them. We like to operate under truly one company. So the customer comes to us, they provide us their part, we're build to print, but we work with them on design assistance and try to be less transactional, more of a technical partnership. But then from there, Cumberland's the name on the face of the door. We take it from there and figure out where to print. Either Pittsburgh, Texas should have no impact on them other than just giving them the best viable option and solution at the end of the day.
But that's what the customer wants. That's truly what they want. They want the best option, which is best for their business. Now I'm curious, is there a limitation on what Cumberland can print for your customers? Are you limited by size? Are you limited by functionality? So let's say a plane, for example, when it hits the ground, there's a lot of impact. Are there limitations of where you can print? A customer comes to you and say, "Hey, Bill, I want to do X, Y, and Z." Like, that's a really crazy idea, but let us look into that and see it. What do those limitations look like?
Yeah, sure. So it definitely can be limited by the build envelope, the size of the printer. We can do anything from a couple inches up to about a foot, just depending on how you orient it and so forth. So yeah, that definitely can be a limitation. If we're doing like big parts on our EOS M400, 400 millimeter by 400 millimeter by 400 millimeter, they're parts that actually fill that entire build plate, X, Y, Z. In other cases, there may be smaller parts, but we can nest them across the build plate and get some efficiencies. I'd say the future of the technology, we've seen it go from one laser to dual laser to now 4 to even up to 12 lasers. So it's become pretty phenomenal in terms of where the technology is going in terms of size and speed. But at some point, you really have to determine where's the limit, if there is one, just depending on your parts needs and the different types and technologies of additive.
What do 12 lasers allow you to unlock? Is it cutting the material? What is the advantage that 12 lasers gives you versus let's say the early days when you only had 2 lasers?
Yeah, sure. So I think we don't have a 12 laser printer. It'd be great to hopefully get one someday, and we certainly have good space for it in our facilities. We just need to justify the right business case and the right volume. So by that meaning, it's automotive, in my opinion, automotive type volumes, really high volume, multiple lasers. Maybe if one goes down, you don't have to stop the build because you got multiple lasers working in tandem there. So I think it's volume and then sheer size of parts as well.
Well, you don't have a 12 laser today. You do have an EOL electron beam melting powder bed fusion system. What advantages does that give you?
Yeah, so that gets back to what I was saying in regards to electron beam versus laser. With electron beam, there's certain advantages, and lasers, there's certain advantages with 2 different technologies. With, I'd say, electron beam, you have cases where you can vertically nest multiple parts in one build, less support structure. In some cases, you're printing and annealing or heat treating one operation, but it just depends. Can the customers accept that part if the tolerances maybe aren't as tight as you would get from a laser component? So it's just all dependent, really. And then just both platforms, you can get access to different materials and open up some opportunity there as well.
When you're sitting here, listeners saying, okay, this is really interesting, and they're wondering, what impact will additive manufacturing have on traditional manufacturing? Will you eventually become friends? Will you become frenemies? Will you be competitors? Where is it going to end up?
Yeah, we'll call it competitors, I guess. So I think there's plenty of room for everyone to play in the sandbox, as they say. I mean, it's another tool in the toolbox. When you apply it properly, it unlocks tremendous value, but it has to be the right part. So I see the industry moving away from, well, can you print this? Well, sure, you can, but should you print it? And that needs to be the key question we're asking. We've got to be printing the right parts. That's adding value to our customers, to our clients, and to society, really, at the end of the day. So I think there's definitely an opportunity for everyone to play in this space together, because you're going to continue to need traditionally CNC machine product, and you're going to need forgings and extrusions. You're going to need a lot of these parts. What additive does, it opens some design freedom and allows us to manufacture maybe parts that weren't necessarily feasible before, or they're good replacement parts to do it more economically because you're reducing weight by taking advantage of the technology. And that gets back to what I was referring to with like the topology optimized parts, where you're only printing what you need and organic type looking components. So it's really exciting to see a lot of those unfold, even with our own product portfolio and space applications as well.
On the backside of that, how do you ensure quality control?
Yeah, so quality controls obviously got to be in everything we do from beginning to end. And I think there's a personification out there where people want to put additive in this special corner, that it needs some type of additional quality than, your CNC machine parts or your forgings. Really, it's another manufacturing process, and it's laser welding. So we're welding, material on top of material. So as we built a technical database over the past 16 plus years, we've been able to demonstrate to our customers like for like that this titanium bracket can get you the same end result from testing specification requirements that you could from an additive manufactured part. So it's process control that's huge, and certainly the people behind that and following the process control, qualifying the parts and components, and seeing that through from beginning to end. Quality management systems very robust. We're AS9100D approved, so a lot of that's built into our DNA and really what we're doing there from a quality standpoint. So process qualification, part qualification, and product testing. I mean, that's what we say is the basic approach to qualification, and where you can get some of that repeatability and AM. So we have a lot of different printers, and we want to see repeatability across different platforms, across different materials. And the biggest way to do that is to build the technical databases and show we've got that process control to our customers.
Is the data one of the key selling points when you're meeting with a new potential customer to show them, and they're asking, well, we're thinking about additive manufacturing, we're thinking about Cumberland, but we're not sure? And that you obviously you're going to show them a part that you manufactured, but then do you also show them the data that reinforces your quality control and reinforces the quality of the product that you're printing for them?
Yeah, absolutely. So you've got some key essential components here. As I mentioned, repeatable process. You've got data and intelligent data analysis, and that all leads to then ultimately building trust with their customers. So yeah, absolutely. I mean, for us, it's data, but it's over a period of time, and demonstrating to them that we can meet the mechanical properties, et cetera, and then getting technical assistance agreements in place to demonstrate to our customers that we have this, we've proven it out. So do you, customer, really need to go down that path of building all this data, or can you look at our data, compare it to yours, and realize we can get there faster? And that's where we're starting to differentiate in the marketplace. And we've been able to bring parts to space, aircraft, for example, fairly rapidly compared to the past. So definitely moving in that direction, and data is absolutely a key component of it.
The overall theme, I would say, of what you're doing at Cumberland is you're increasing efficiency. I mean, that's really, when I think about it, and efficiency really helps businesses scale. We talked about aerospace, we talked about defense, we talked about space. Are there other major markets that Cumberland's working in where you have customers from other segments, perhaps automotive or traditional manufacturing? Are there other major markets that you're actively working in?
Yeah, so we've gone through the pandemic as a small business. If you rewind, I hate to take you back to that challenging time, but we kind of hunkered down. We looked at our markets. Aerospace obviously had some serious headwinds. And so we started to strategically diversify our market portfolio in doubling down in space applications, which is one you alluded to. But then also we're striving to diversify into medical, and we're going down that path. There's a lot of good opportunity for additive manufacturing and medical components. And then certainly automotive as well. And we recognize we can't be everything to everyone. So we really try to stay vertically focused. But if there are certain, procedures, processes, QMS, AS9100D type customers and markets that we've already got the foundation, and we just need to tweak the recipe a little bit, and we can get there fairly quickly, and there's good opportunity, then that's been our next, logical step. And then we actually do a lot in energy. So we power gen, oil and gas, a lot of flow control devices, disc stacks, where you have components that traditionally may be manufactured through sheet metal and kind of braze layer upon layer, whereas we're able to 3D print one monolithic piece, printing in these tortured channels and pathways that otherwise would be challenging to do with different processes. And a lot of these are product families. So they may have different designs, but fall within the same product family. And we don't have to tool up for each one of those. We're able to print those specific geometries in those product families and do it pretty repeatably and at good volume.
It's a great time to be in the energy business. Merger Monday is alive and well. You have ExxonMobil buying Pioneer Resources. You have Chevron buying Hess, and Mr. Mike Wirth, the CEO of Chevron, I'll say it here, it's very important. They're still going to have the Hess truck for Christmas. The Hess truck is part of the deal. It was actually written in the contract that the Hess truck stays. So, and then the International Energy Association saying peak oil at 2050. So that's energy and oil, and that is a very big growth market because all the refining coming online. Medical's interesting. A buddy of mine had a hip replacement the other day, and he came over 3 days later. I was like, what the heck are you doing over? So, well, I'm thirsty, so I poured him a glass of wine. I said, how you doing? He's like, oh yeah, a robot did it for me. And it was amazing that a robot did his hip surgery. When you say medical, are you trying to put the parts on the robot that did my buddy's hip surgery? Or where in the medical spectrum are you 3D printing stuff?
Yeah, well, look, I look forward to the day where we can print that part and your buddy can even pick it up from our facility and walk it into the surgical room. Maybe never even encounter a doctor, talk to the machine and have them insert that part. Now, the advancement technology, they're incredible. What we would be 3D printing are like surgical instruments, but also implants as well. That's definitely a place because titanium 6.4, for example, it's biocompatible, promotes bone growth. So good material. There's other materials they're using for medical as well. And in some cases, if you take electron beam technology, the surface finish versus lasers I alluded to earlier sometimes can yield well for that bone-to-bone interaction within the body.
Cumberland's full of growth markets. I don't know any other way to say it. You're full of growth markets of where you're going. Overall, how do you see the additive manufacturing sector growing? Obviously, we have the growth markets. Do you just see gaining market space in those sectors, or do you perhaps see another sector coming online over the next decade?
I must say, while we're growing and it's rapid, that comes with challenges as well. So it's not all roses and sunshine. We are working close with companies because you have to change cultures, right? You have to get additive in the DNA, but we definitely have a good head start. So there's organic growth within those companies where they're further down the adoption of additive manufacturing curve. They have parts on vehicles and in space and on aircraft and automotive, so forth. That in there we look at and work together to say, okay, how do we design more parts for additive from bottom up and looking at future aircraft? So air mobility and taxis, I think, would be a good future place for additive. To get back to your question about the future, I think getting closer and closer to the end user, to coin the words of defense, getting closer, bringing capability closer to the warfighter, extending space, where we can have printers on spacecrafts and they're able to print out maybe a part that broke. So it's definitely going to move further that way. But I think there's a limit. It just depends on the rigors of the component and what's required there. And can you have that printer by your side, or does it need to be placed, back at a facility? So I think the future's bright and we're excited to what's to come here.
Let's narrow focus this. What's the future for Cumberland Additive?
Yeah. So I would say for us, continue to fill out the existing facilities, but also I would say, strategic acquisition. So stay tuned. We continue to have big things happening within our company as we look to grow and acquisition where companies fit our culture and have, that vertical integrated growth, both in our markets, but also, with our synergistic customers is a logical next step as well. So as a small business, I think that's key to us too. We want to continue to remain a small business and maintain that differentiation through, agility and responsiveness to our customers. That's important to us. We want to have the pedigree and the history of big companies with the right processes and foundation, but we certainly want to maintain that small business nimbleness, which allowed us to get through the pandemic, allowed us to come out stronger and diversify into these markets, to open up the Neighborhood 91 Pittsburgh facility, and then to now start looking at big acquisitions and keep building this connection between Pflugerville, Texas, and Pittsburgh, PA, where our current locations are.
And if you have customer service as you scale and grow, it all goes together and all complements other. Because if your customers are happy, the business grows and allows you to do those acquisitions. Bill, as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Yeah, well, first of all, thanks for the time and for listening in. I would say additive, it's a challenging business. It's capitally intensive, but if you got the right people and you got the right process and technical know-how, and you have those technical chops to know what to do with the data, how to apply it, it can unlock a lot of value for society and certainly pay dividends for the future of where we're going with, space travel and aerospace and air taxi and medical, extending life, et cetera. I'd also really encourage people to continue investing in STEM. So we need the next generation of students. They're critical to the future and continued growth. There's certainly a lot of challenges ahead for internationally for our country, et cetera. But I think we're up for the challenges, and I think additive is another way to knock some of those barriers down. It's just going to take one print at a time, if we'd say.
America is always up to the challenge. Additive manufacturing is the future. Today is tomorrow. Tomorrow is today. The future is Cumberland Additive. Bill, thank you so much for coming on SAE Tomorrow Today.
Thank you. I appreciate the time.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next. Be sure to join us next week as we speak with Daniel Barrell, co-founder and CEO, Re-Automotive. He'll discuss the first fully X-by-wire platform on the market that increases vehicle stability, responsiveness, and safety.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.